So, what did I just tell you a series was back when we were defining terms?
The sum of the numbers in a sequence.
The sum of the numbers in a sequence. So in this case, I want the sum of the numbers in an arithmetic sequence. I'm summing up the numbers in an arithmetic sequence. Okay, so we could start. We're going to sum this up. Gentlemen, stop it. Blue, I can always assign C. Okay, first of all, when we want to sum the numbers up, there is a symbol for the sum. Looking at your little chart on your sheet of paper, would you care to guess which one means?
That little FN.
Okay, the sigma thing means the sum of all the terms, but as far as in a formula, we write S of n, the sum of n terms.
So can we just write that little E thing besides S of n?
I'd rather you didn't. I'd rather you write it in words, so if you come back to this, you're taking some college class and you come back to this and go, what was that? You got it. So S of n means you're going to sum up the terms.
I'm going to college.
So, once again, I want you to be able to find me the sum of 100 terms or 500 terms. We don't want to have to, and we don't want to sit there and add them all up on our calculator one by one. So we're looking for a formula. This one's not quite as obvious, but I'm going to show you the slick trick of arithmetic sequences. Okay. We're just summing up 4 terms. Can anybody tell me the sum of those 4 terms?
No.
Oh, what's the V left? 28.
9 plus 19.
I said 28.
28. We all buy 28?
No. I even said it like a nerd.
Oh, whoa, sorry. That's supposed to be 14. I'm
Well,
going.
that's not 28. That's not 28.
So now it's 38. Sorry. It wasn't an arithmetic sequence if I didn't make that go up correctly. So is it still arithmetic? Is each number going up by the same amount? Yeah, it's going up by 3's every time. So that's still arithmetic. Okay. To find the formula for we've added up to 38, no big deal. But if I said add up the first 400 terms, y'all wouldn't want to list them out and add them up.
That's right.
Okay, but I'm keeping this small to keep it under control. To show you how this formula comes from, I'm going to rewrite this list of numbers. But I'm going to write it in reverse order. Well, watch what happens. When you reverse an arithmetic sequence, add these numbers. 5 plus 14 is 19. 8 plus 11 is 19. 19, 19. So if you reverse the numbers in an arithmetic sequence, they will always add up to the same value. Okay, but since I've added those twice, I have an S plus an S, so now I have 2 S's. 2 S sub 4 because I'm doing 4 terms. Okay, all right, if I need to add 19 up 4 times, or I need to multiply 4 times 19? I have 4 19s, right? Isn't that the same thing as saying I have 4 times 19? Okay, which would be 76. Okay, I want to solve for S. Divided by 2, and I'm back to the 38 that we knew was the answer. Okay, now how can I turn what I just did there into a formula? Actually, not hard.
Okay, I got it. I bet it's the S in
Okay, so the first thing I had to do,
N times.
I took 4 times 19. Where did I get, why 4? Why did I have 4 times 19?
Number of terms.
N is the number, 4 is the number of terms, so I had N. Okay, where did I get the 19 from?
You got it because you added the terms.
Okay, added the terms. In this case, though, 5 and 14 were which terms?
First and last.
The first and last. So you got it by adding, you got 19 by adding the first and the last. You took it times N. That got us 76. Then what did we have to do? Then we had to divide by 2 at the end. They usually put the divided by 2 out front rather than in the parentheses. And you just found the formula for summing up any number of terms in a arithmetic sequence.
It's still terrible.
It's not terrible.
Where's that on our journal?
Somewhere, it should be down toward the bottom in the listing.
Is that part of A? Is that another part of A?
Arithmetic sequence and theory formula.
Yeah.
Two points. But I've only got one formula. No, I got two.
So now you have two formulas.
Nope, but I only got two.
Well, I gotta show you how to use this, and I gotta convince you why somebody in rural cares.
Pineapple tree too.
So, that's the formula. First we're gonna work a problem, then I'll show you an example of why we care, but can I switch screens? Okay, I'm switching screens. Actually. Alright, so suppose I said, what would be something fun?
69.
So you guys know
Can you see the white or not?
Yes, you use 64. Same colors, of course.
Okay.
Add 5. Plus
5, fine, okay. 64 plus 69 plus 74 plus ... And I want you to sum it up to 9,000 terms?
No, just the number 9,000.
Oh, to the number 9. Actually, well, we need to do it both ways. So, but how do you know 9,000 would be in the sequence?
Because I was a lucky guess.
You divide it by the first number. No.
I know for sure 9,064 would be in the sequence.
Okay.
Okay.
How do you know that?
Because if it's going up by 5.
69.
Yeah! Okay. So, I'm saying you find me the sum. Which formula should you use?
Wouldn't 9,004 be in there?
Theory one, we have the S1, the N1.
Okay, so I know I need to find the sum. It wants me to sum up. There's plus signs between them. You see plus signs, I want you to sum it up. So you know you're trying to find the sum, so you need to go try to fill in your formula. Okay, so
9,064.
do I know how many terms I have?
No.
No, I don't. Okay, skip that. We'll come back to that. Do I know anything else here? Do I know the first term?
First one.
I know the first one's 64.
9,000.
I know the second one's 9,064. How am I going to figure out how many terms I got? What's n?
9,000 divided by...
Well, the good news is most of the time when you're doing these problems, you have to go use the other formula to find something you're missing. So most of these problems will require you to go use both formulas to get parts you need. So I need to use this formula to solve for n so I can fill it in over here.
Yeah, 9,000.
Well, let me point that out here. What's the last term? 9,064. What's first term? 64. And the difference? 5. So in this case, yeah, because I chose to use a nice even number like 9,000 is what I added on. Yeah, exactly what you're saying is happening. Because what's going to happen when I try to solve for n?
You subtract 64.
I'm going to subtract 64, which is going to get me to 9,000.
And then you're going to subtract what?
And now you can work this two ways. You can distribute the 5 and solve for n, or you can divide the 5. Whichever floats your boat. So if I do 9,000 divided by 5, that's going to go, well, maybe 1,800 times. And then lastly, what do I need to do?
Add what?
I'm not even paying attention. So once I know 1801,
Then you put that in the thing.
then you can put that over here.
That's that rotten marker stuff. Yeah.
And so now you're probably going to want a calculator to crunch this because it's going to be a pretty good sized number. And I actually need somebody to punch it because we just made up these numbers. I don't know the answer.
Luke, wake up, no one punch it.
Just the marker.
Wake up, Luke.
You know what, you have it open.
Okay, so 8219764. Right? So in other words, the total of that particular sequence would have been over 8 million. Folks,
Convince me.
all right, so we've all been to large basketball, football arenas, something like that. Okay, and in many arenas, you'll notice the seats are kind of in pipe-shaped sections.
Oh, okay.
Yeah.
I see what you're saying.
So like maybe this first row down here, maybe it only has 4 seats in it.
Oh,
And then the next row, we've got 6 seats in it. Then you've got 8 seats in it, and keep going because it keeps getting wider as it goes up. Okay. So my first question to you is, if this thing ends up having, well, maybe. There we go. If it ends up having 20 rows in it, how many seats will be in the last row?
It'll be the arithmetic sequence, right?
Why?
So you told me that they don't.
It's going up by 2 every time.
Okay, it is going up by 2 every time, so it's arithmetic.
Sequence or?
Okay, so the question is, now, are we summing up? Are we summing up all the seats, or am I just needing to find a certain term? I just need to find a certain term here. I just want to know how many are in the 20th row. So that means I should use which formula? The a sub n or the s sub n? Yeah, in this case, I want a sub 20. I want the 20th row. So according to the formula, I need to do first term plus. Okay, so 4 would be my first term. Where do you get 2? Why is it saying 4 plus 2? The difference is going up by 2 every time.
20.
And we're doing 20 rows.
Alright.
And so that's actually going to be 19 times 2 is 38, plus 4 more is, that would put 42 seats in that top row. Okay, if you're the designer you're the engineer designing this place. Do they want 42 seats in one big long row?
Yeah.
Do you, the person, want to, if you have the 21st seat, do you want to have to call over 21 people to get to your seat? No. And typically they'll drop some little half aisle down part of the way so you can get down to your seats or something. But assuming they didn't, okay, this one's got 42. Okay, my next question to you is, the ticket office needs to know actually how many total seats that is in that section. How many people can they sit in that section? So how do I find out how many total seats are in this section? That's the series because I need to sum them up.
Yeah, just get a bunch of people and go fill it up and then count it.
That's oh so efficient.
It is. It's efficient. And it takes less time.
Why do you even need to fill it up with people?
Counting the chairs is too hard.
But first of all, if you're the guy designing the thing, you got to know how many seats are going to be before you ever build it.
People sit cross-legged. I just assume.
So I need the sum of all 20 rows. So in this case, what's n when I want to sum this up? There are 20 rows. Your first term is 4. Your last term is
42.
we fortunately already figured it. It's 42. So that's going to be 46 times 10, or there are 460 seats in that particular section.
Hey, shut up.
Please, I'm so sick of your mouth.
Hey, you're at 1427.
Oh, look, I am. Doggone it. I wanted to get this done. I got one more thing I need to do. Oops, you're not.